My name is Kate Perardi, and I'm going to be sharing with you what I have been doing for the past 16 weeks in my master's program at St. Mary's University. I'm getting my master's in learning design and technology, and I have been working on a design thinking challenge for the past 16 weeks. It all started with a problem, and my problem really revolved around my learners having trouble applying their math in other situations and transferring it and remembering it. So my design thinking question was, how might we redesign or reimagine the math experience for advanced learners in order to increase transfer and application? So I went to all those affected by this problem because all of us together can create a solution, instead of me trying to solve this problem by myself and get frustrated. So what I really wanted to learn from my stakeholders was what is and is not working for the kids in the math experience. What do the families want? What are their hopes and dreams for their learners? The history of the GT system and changes along the way, and the math vision for the district from the math specialist, and how all connect math to the outside world, as well as if I could implement service learning in the math curriculum. What I learned and heard was that math needs to be applied and connected to the real world. Data is huge in many of the lives of my learners and their families. Many families feel that math is necessary and leads you to a successful life. There is lack of application and connection parents feel in the math that we currently teach. Many students either thought math was everything in their world or it was the four basic operations. Parents want their kids to be exposed to many perspectives, and the math ability of many learners was addressed along with the social and emotional needs. Math is all around us, and we needed to find a way to bring that into our learning in the classroom. After we finished our first part of the equation, which was the qualitative data, we moved on to quantitative and we started researching. Some of my major concepts and themes I'm going to tell you about. One of the major themes was that we must focus on the math concepts, and with that, we must focus on concrete, representational, and abstract ideas. Zimmerman, Daniels, and Hyde, Wiggins and McTighe, Bowler, Willingham, and R7 all supported this. We also must show multiple representations of the concepts we are working on. Another theme was how do we construct understanding and really engage learners in math. We must find a bridge, and the bridge must be formed between the prior and new knowledge for understanding to truly happen. Vendetti, Matlin, Richland, and Bunge, Zimmerman, Daniels, and Hyde, Wiggins and McTighe, Ferner, Yaya, Duffy, Willingham, Haiti, and Yates, R7 all supported this idea, along with the exploration of concepts. When learners are exploring the concepts, they are developing reasoning, number sense, and a foundation of math. They're not just focused on the answers or procedures. Carter, Zenman, Daniels, Hyde, Wiggins, McTighe, Bowler, Ferner, Yaya, and Duffy, Willingham, White, Clark, Orland, Greens, so many of my resources were supporting the idea of exploring, focusing on the number sense and reasoning, and letting the learners construct their understanding of a concept instead of just be told the procedure and figure out the answer. Along with all this constructing of understanding, there must be a time for reflection, because reflection offers insights and awareness of misconceptions. As we are constructing understanding, there must be assessment of math concepts in many forms. They must be diverse, frequent, and tell us how the learning is going. By us, I mean me, the learner, and their families. Along with our construction of understanding, math communication is a huge concept to focus on. Learners must be given time to communicate, explain, and gain understanding. Learners must be asking questions and digging deeper into their wonderings. Nathan, Wallington, Pierre, Williams, Carter, Zenneman, Daniels, Hyde, Bowler, Ferner, Yaya, and Duffy, Willingham, Carter, Bowler, Derching, and Greens all supported these ideas. Those are just some of the major concepts and themes from my quantitative data. We are getting closer to the sum of this long and complex equation. I took the qualitative and quantitative data and put them together to design and figure out what my design needed. And these are the 6 design principles that I decided my solution needed to have. This led me to begin to prototype a solution to help me answer the question and begin to solve the problem of how we might redesign and reimagine the math experience in order to increase transfer and application. And my solution and prototyping was called DIG. Now, what does DIG mean? This is an acronym for how the math instruction would happen in our environment. D is for discover. So the learners would be in discover, they would become aware of their prior knowledge and begin to utilize this. They would be introduced to a big question or a problem that they're going to try to solve, and they would discover how their number sense, prior knowledge, reasoning, and questioning is all going to come together as they begin to figure out how they want to come to a solution. So learners are accessing their prior knowledge, planning and modeling and creating new understanding. They are accessing a concept instead of just a simple procedure. The concept would be real world and they would be going deeper with it. They are focused on number sense and they're going to be communicating with other people. So this is hitting a lot of the design principles and the themes that were coming out in my research. I is for investigate, so the learners would be given time to create the concept and their understanding that is underlying the whole question and problems. They would be engaging in collaboration and communication. They would be trying out different models, focusing on concrete, representational, and abstract ideas. They would be developing more number sense and reasoning. They would be talking and engaging and exploring. They would be taking their new knowledge that they are coming up with and creating and connecting it to their prior knowledge that they accessed in the D discover stage. And the last stage would be G is for grow. They would be sharing out their solutions and representations of their problems. So they would be showing their concrete, representational, and abstract ideas. They would be reflecting as a group independently and as a whole class. Learners would be communicating to others and asking questions of themselves and being exposed to many different perspectives. And at the end of this, they have constructed understanding on a concept, a real problem that can be applied. In the G stage, they might also apply what they've learned to a brand new idea. And after they've gone through D, I, and G for dig, they will have built that bridge between their prior knowledge and their new knowledge. Our 16 weeks of these 2 classes are up, but the learning is not over, and I am not done facing this challenge, but I'm not going to be in this alone. I need all of you to come along with me as we continue this journey. I need you to continue to ask questions and talk about the math, and take your time praising the time and effort that it takes to really understand a concept versus just go for the right answer. I need you to continue to push people to change their math mindset about what they think math is and what they think their math ability is. As I continue to dig deeper into this and push forward with you and my learners, these are some other ways you could contact me. There's my email, you can get a hold of me on Twitter, and also you can see more about what I have been doing during this process, more of the ins and outs at my blog. Thank you so much.